The word algorithm refers to a precisely defined sequence of steps to solve problems or tasks. The algorithm game is based on 3 different game ideas that build on one another, with the idea of explaining what an algorithm is and how it can be used to achieve certain goals or results, and demonstrates this principle using examples from everyday life. In example, the way to school. For game idea 1, the 7 picture cards are placed in the middle of the table. Different activities are shown on the cards, illustrating what Cody and Pixie do every morning. The idea is to help the twins find the right sequence of steps. In example, arrange the cards in logical order. The players think about the order of activities. In example, which come before or after the others. For example, getting up comes before cleaning teeth. But what about breakfast and getting dressed? Once the players have decided on the order, they lay the cards in this order side by side. The figures are then used to go through the individual steps. Are they in correct order? Are there several different solutions? For example, if the twins have their breakfast before they get dressed. An algorithm has a precisely defined series of logical sequences, which can, however, have different variations. Some variations, however, don't make sense. In example, getting dressed after going to school. The sequence of steps can depend on certain conditions, and this is demonstrated on the T-shirt or rubber boots game variation. Here you have to decide what to wear depending on the weather. What will the weather be like today? Take a look at the weather cards. The sun stands for dry and warm, while a rain cloud means it's cold and wet. Stack the weather cards face down and place the clothing cards face up in a grid. Now position one of the 2 playing figures next to the cards. Turn over one weather card. The players then take it in turn to decide which item of clothing suits the weather and places it next to the playing figure. If it's hot, I'm not wearing rubber boots. In computer jargon, this is called an if-then instruction, which is used in most computer programs. In the 3rd variation of this game, a set of instructions is encoded, and you learn about loops, a word used to describe sequences which are repeated in programs. For this game, you will need the game board, all the coding cards, and the playing figures. The aim is now to get Pixie and Cody quickly and safely from their house to school. Start by placing the corresponding building cards on the game board. They can be placed anywhere, except on the roads, and they should be placed at a good distance apart rather than next to each other. Put the crosswalk cards on the roads to mark where the twins can safely cross them on their way between home and school. The coding cards contain the instructions available for the way from home to school. In example, walk straight on, turn left or right, or look left and right. The players then decide in which direction the playing figures need to move around the game board. Each sidewalk or crosswalk field counts as one instruction. The coding cards are now used to create a code which, next to the game board, plots the way to school. In example, a set of instructions for the twins to follow. How many fields do the figures have to walk straight on? When do they have to turn left or right, etc.? At the end, there will be a long row of cards on the table. The players then move the playing figures step by precisely following the set of instructions on the cards. If Cody and Pixie arrive safely at school, the code was correct. If not, players need to check the code again to find out where the error was made. On the way, it can be that several consecutive fields show the same instruction. In example, 5 fields straight on, represented by 5 coding cards with the straight on arrow. A computer uses a loop to represent instructions which are repeated. In the game, the loop starts card is placed, then the instruction, in this case the straight on arrow, and at the end, the loop ends 5 times card is placed. 5 cards then become 3 cards. The code becomes shorter. Other exciting explanations on programs, conditions, and loops can be found in the instructions.